So we're talking about models of the atom. That's our title up there at the top. And we're going to go in chronological order, the major models of the atom that have been discussed over the last few hundred years. We're going to start with the Dalton model. Dalton is somebody's name. His name is John Dalton. Generally in science we refer to people by their last name only. And so this is his model. The name that we sometimes give to this model is the billiard ball model, more or less because that's what he thought an atom looked like. So this is the name of the person, and then that's the name of his model right there. So Dalton had a few things to say about what an atom was like. I'm not writing every single thing he said here. There's actually a ton of stuff. I'm trying to pick out the important points that I would want you to know about. According to Dalton, the first thing that he said was that the atom was the smallest particle of matter. And this point, people would agree, still true. So he was not wrong about this. Now yes, there are other things that are smaller than an atom, but once you split an atom apart, we have a hard time defining it as matter because of the whole mass volume thing. And so we still would agree that the atom is really the smallest unit where we could discuss matter. Now the other two things that were part of Dalton's theory, one of them was something that he didn't say. He didn't say anything about there being charges. And so this point, not technically true anymore. So since this model came about in the past, we have new information that tells us there actually are things that are charged. Now, if John Dalton had said something to the effect of, it had no net charges, then he would have been correct, because we would still agree that that's true today. And so I'd like to know, does anyone know what the word net means? For example, do you have a job where you get a paycheck and at the bottom of your paycheck it says net pay? Does anyone know what that means? Net pay? How many of you have jobs where you get paychecks? You got to educate yourself about what they're actually paying you. Make sure you're not getting ripped off. Net pay is what you get paid after they've deducted whatever tax and whatever dues you have off of your paycheck. So net is like the sum total of everything. If I look at an atom, it doesn't have an overall charge. So overall, it's not positive or negative, but there are things inside of it that are. And so according to Dalton, he didn't know anything about charges. There was nothing going on. If he had said there were no net charges, he would actually be right. That's true. The other thing he said, which we would not agree with anymore today, is that an atom was one solid sphere. So think of a little billiard ball. Like if you have a pool table, the balls that are on those are billiard balls. That is the image that John Dalton was giving of what an atom looked like. So in his time, they didn't know anything about what was inside of an atom. They knew that they existed and that matter was made up of them, but nothing beyond that. Would anybody like to ask any questions about John Dalton's model? Model number 2, the Thompson model. His name is actually J.J. Thompson. I don't even remember what the J and the J stand for, probably like John James or James John. But Thompson is his last name. Here is his name, and this is what we would often call his model. So Thompson's model was called the raisin bun model. Sometimes it's also referred to as the plum pudding model, depending on who you're talking to. Someone this morning asked me, is that what Thompson made up? Like, did he make up that name, or did we add that after the fact? And this is an after the fact thing. He came up with the theory, this cute little name got tacked on afterwards. Now, according to him, still, the atom was a solid sphere. So notice, that's a point of similarity between this theory and the one that came before it. And what I'd really like to try to do is show you how each model of the atom was similar to the one that came before it, but added or changed something about the theory to make it slightly more correct. Now here's a point that we would agree is true. There are, in an atom, positive and negative charges. So Thompson was not wrong about that point. He was wrong, though, about it being a solid sphere. And so that point, just like it was wrong for Dalton, was wrong for Thompson as well. So he knew there were charged things, but perhaps the way they were organized was something that was eluding him. If you were to visualize what Thompson was thinking, he was thinking that this was an atom, it was a big solid thing, and that somewhere in there were positive and negative bits, but it was one big solid chunk. There was no space in between the positive and the negative parts. Another point that's similar to the theory that came before it, which we would still agree is true today, is the smallest part of matter. So realistically, he thought more or less the same thing that Dalton thought, except that he added the idea about positive and negative charges being part of the atom. So this would be the point that is different. Other than that, he thought basically the same thing that the guy before him thought. So often in science, when people come up with a new model, it's not that they have a brand new unique idea, they take someone else's idea and build upon it. Does anyone have any questions about the Thompson model they'd like to ask? So the Rutherford model comes next. Again, Rutherford is his name. The planetary model is the name of the model. Now his model was called the planetary model because according to him, an atom kind of mimicked what planets do in the solar system. So according to Rutherford, the atom was composed of a positive nucleus and separate, that would be like a key word here, separate negative electrons. According to him, the electrons were, without an H, so it's spelled properly, were orbiting the nucleus. So if I was to try to visualize what Rutherford's model looked like, I would imagine something like this. I would imagine a nucleus. The nucleus is the center piece of it. And then around the nucleus, I would have things orbiting. A lot like planets orbit around the sun. And so his idea was that the nucleus was kind of like the sun, and the electrons were kind of like planets. They were around the nucleus. So, what did he think that was different than the guy that came before him? Well, he no longer thought that the atom was a solid sphere. The distinction here is that there were separate parts. The atom was composed of a positive nucleus, that was one part, and then around that, outside of it, there were electrons that were negative. He still thinks the atom is the smallest part of matter. That part hasn't changed. He still thinks there's positive and negatives, just like Thompson did. It's where are the positives and negatives that have actually changed in this model. Would anybody like to ask any questions about the Rutherford model? So the model that comes next is actually the one that we still use, even though it's not the most current one, but the one that we still use to draw things. And so just before I move the screen over to the other side so that we can see that, is anyone still writing what's up here and need to see this? We're good? So next, we have the Bohr model. The Bohr model is often referred to as the electron energy level model. I've also heard it referred to as the nuclear model. I prefer electron energy level because it's more descriptive. Now here's what Bohr said that's different from what Rutherford said. So Bohr still thinks there's a nucleus, he still thinks there's electrons, he still thinks the atom is the smallest part of matter, but what he's adding or changing is that electrons occupy specific energy levels around the nucleus. So according to Rutherford, electrons were just zooming around, kind of however. Bohr specified that when we look at an atom, there are specific levels. If I was to draw an atom, according to Bohr, I would still start with the nucleus in the center. And then I would draw specific levels. I'll start by drawing 3 because realistically I don't think I'd ask you to draw more than that. The first energy level, so the first orbit, the first circle around the nucleus, could potentially hold 2 electrons. So on my picture here, I illustrated with the purple dots that on the first level, the first orbit around the nucleus, at most, I would find 2 electrons. If an atom had more than 2 electrons, I would have to move outwards to the next energy level. The second energy level could potentially hold 8 electrons. And so on the second circle, I could draw 8 little dots. The third could also, at most, hold 8 electrons. So I could draw 8 on the third level as well. Now once we go past that, once we get into bigger atoms, it becomes really tedious to draw them in this particular way, and I wouldn't ask you to. And so even though I've indicated the 4th and 5th levels, it actually goes all the way up to 7 levels. 7 different levels that the electrons can be in. I'm not going to ask you to illustrate that ever. But in the next section, where we start talking about new official Science 10 stuff that I wouldn't think would be review, it would be important to me that you understand that there's a limit to how many electrons can go in each level. So what did Bohr change? He added the idea of specific energy levels. The electrons aren't just orbiting wherever, they're in particular levels, and there's a maximum number that can be in each level. Would anyone like to ask any questions so far about the Bohr model? So I'll just move it down a little bit. The last point, I'll just wait till people are ready. I don't want to move the picture too far out of the way. But the last point is talking about how we can draw things. And so if I know this, I can draw diagrams. And I'll move the screen down in just a second, but I wanted to highlight the word draw. When I draw atoms, even though the Bohr model is not the one that's the most current, it's still the one that's used most frequently to illustrate what's going on in an atom. And you'll see why when I show you the last model, because it would be really hard to draw the last model and make something visual out of it. Is there anyone who would mind if I move the screen down just a bit? Does anyone need what's at the top still there? Whoops. So, from the Bohr model, we could draw energy level diagrams for the atomic structure of the first 20 elements. And the first 20 are the ones that I would ask you about. So in the next section where we get really specific about what is an atom composed of, how do I know how many electrons there are, how do I draw this, I could ask you, using the Bohr model, to draw the structure of an element. And so if I ever ask you to draw an atom, it's the Bohr model that I'd like for you to use. Now the last model is called the quantum mechanics model. And you'll notice I didn't even put a person's name associated with it. And that's because there isn't really one person. There's a whole bunch of people who collaboratively have come up with this model. It's also sometimes called the electron cloud model. And so if I was to illustrate this last model, instead of showing the electrons all nicely laid out on beautiful little orbits like the Bohr model did, I would draw something like this. A nucleus in the center, and then sort of a hazy looking cloud around it. And so you can see perhaps why that might not be the most clear type of diagram to use if we're trying to illustrate the structure of an atom. The idea in the quantum mechanics model that's different from Bohr's model is that electrons travel between energy levels. In other words, an electron does not have to stay in energy level number 1. It could move to energy level number 2. An electron from energy level number 2 could move to energy level number 1. So electrons travel between energy levels. The result is that there's only a probability of finding an electron in a given orbit at a given time. There's no guarantee that that is where that electron is going to be. So according to Bohr's model, an electron is in an energy level and it stays there, and it doesn't do anything. Quantum mechanics says, actually, the electrons are constantly zinging around, and so I'll probably find one there, but I can't be sure. Now those are the 5 models. And I know some people are still writing things. Does anyone have any questions they'd like to ask right now? So that'll be the end of me recording a video today.